Hi, my name is Danny Huck, math specialist here at the Learning Commons, and we're going to be going through test 4 review for Mac 1105C. What this covers mostly is exponentials, logarithms, as well as like inverse functions, so everything that you're going to see on your test, which some of them are today, due tomorrow, some of them are tomorrow, and some of them are next week. So this should help you prepare for that. To do that though, I'm going to go ahead and share my screen here. Can you guys see it okay?
Yes.
Awesome. And then I'm going to pull chat up on my other screen. So you're more than welcome to reply in chat, but you're also very welcome to unmute yourself as we go through and work on these problems together. And that being said, let's take a look at question number 1. So question number 1 deals with population of bacteria. And it says that the population of bacteria is growing according to this equation. P of t equals 1950 e to the 0.04 t, where t is the number of hours. And you want to estimate when the population will exceed 2570 and give your answer accurate to 1 decimal place. What's important to note here on this equation, P of t equals 1950 e to the 0.04 t is what each of these parts mean, because in some cases you might be asked to set up this equation beforehand rather than just be given it. So it's important to know what each one's mean. What does the 1950 mean? What is that? Does anyone know? What that 1950 represents? And again, I'm checking the chat, so if you want to throw your answer in chat, you can private message me it too. I am paying attention. Where do you think they got that 1950 from? Yeah, absolutely. This is the population, or more precisely, it's the initial population. So this is how much they started with at t equals 0. Okay. And what about that 0.4? What is that 0.4? Or 0.04, sorry, my bad. We got t as the time. We got the initial population. So what's that 0.04? You're on the right track. We're not talking about time here though. So the 0.04, you multiply it by the time. That's super important. But maybe if you threw a percentage sign on the end of that and moved the decimal over 2 places. So what is this? The 0.04. Yeah, it's the rate. So this is the rate at which this population is growing. The bacteria is growing. It's really important to note that with the equation, because in some cases you'll be asked to set up the equation. And so it's good to know what each thing represents. Okay, what this specifically is asking is to estimate when the population exceeds 2570. So 2,570 for the population. So where do we put that into, where do we plug that into our equation? What are we solving for? Are we solving for P of t or are we solving for t?
T.
Yes, absolutely. We are solving for t. And the reason we're solving for t is because we want to know when. So since we want to know when, this t gets left alone and this gets plugged in for P of t. Okay. And I'm just going to rewrite this now with what we have. So now we're solving for t. What is our next step here? If we're solving for t, what's our next step? What do we need to do to get t by itself? You're on the right track. We are multiplying, or in this case, because this is multiplied, we are dividing it. We got to get that e by itself. Now, you can reduce this if you want. Honestly, I would just wait until the very end with the calculator part, because that tends to be a little bit easier to do if you just put it all in the calculator at once. It also means that you're not rounding to the very end, so you're going to have a more accurate answer. Okay, so now we have it into this form. What can we do to get t by itself? Right now it's e raised to the 0.04 t. And by the way, if you haven't, please put your full name in chat for recording purposes. So I can get that to you. And you can direct message that to me if you're more comfortable with that. Thank you. Okay, so I don't know if you remember, but there was like a super important rule about logarithms. And it kind of went like this. So first off, you could interchange it. Does anyone remember what you could interchange with logs? This kind of looking familiar.
Exponential.
Yeah, this was the, if you have something that's a log base a of x equals y, you could change it into an exponential. Well, what we have here is the exponential. So what we can do is change the format. And by changing the format, that will allow us to solve for t. So in this case, and you can do it that way, or you can just take the natural log of both sides. It's going to do the same thing. Okay. And I will show you. If you treat your a as your e, do you guys see that right here? Your y is your 0.04 t, right? And then your x is the 2570 over 1950. You guys see that? So if we rewrite that, it's natural, we'll do natural log because it's base e of x, which is 2570 over 1950 equals y, which is 0.04 t. Does that make sense? The other thing you can do, and again, this gets you to the same place, is you could just take the natural log of both sides. What does the natural log base e of e to any power equal? And it kind of looks like, I'll do it over here in another color. Natural log base e to the e of x. What's that equal? Close. Not 1. If it was just natural log base e of e, absolutely. But it's natural log base e of e to the x. So instead of 1, it equals x. So if we compare that to what we have here, we have natural log base e of e to the 0.4 t. What we're left with is 0.04 t. And so then you have natural log 2570 over 1950 equals 0.04 t. See how it's the same? Doesn't matter which rule you use. Either rule will get you there. It is important to know both for different situations, but that is the case. So once we're here, what's our next step to get t by itself? Yeah, you're going to divide again, absolutely. So it'll be the natural log of 2570 over 1950. And then here we've divided by 0.04. So this whole thing is divided by 0.04, and that equals t. And then what you're going to do is you're just going to go to your calculator and you're just going to type it in, the natural log of 2570 over 1950 divided by 0.04. And it also helps if you don't draw right in front of where you have the answer. There we go. Okay, so our answer is t is approximately 6.90191, keeps going, right? So if we look back at what it's asking for, give your answer accurate to 1 decimal place. So 1 decimal place, so approximately 6.9. Okay. And if we test that, there you go. Any questions about this, this question? Any questions about this question? Or how it works? Okay, and remember, on the left-hand side here, we used the definition. And on the right-hand side here, we just took the natural log of both sides. And then we used what we know about the rules of logarithms to get to the same spot. So either one will work. I would recommend, if you don't know this that well, that you make it your best friend. It's phenomenal. It saves you in everything involving logs. So okay, I'll stop bragging about my love for logarithms, and we'll continue. Okay, so this one just says evaluate using your calculator and round to 4 decimal places. Pretty standard. If however you do not have a calculator that allows you to change the base, which means you're using a TI-83 calculator in most cases, then we'd want to use the change the base formula. Does anyone remember that? Something like A to B is log over log. And this is, remember when it's just log, it's base 10, we don't have to worry about it, but it's usually log B over log A. So if you absolutely had to do that, it'd be log what over log what? What number's on top, the 96 or the 3?
3.
Close. Take a look here again.
Where's
Where's the
96?
Yeah. Okay. And again, that's if you're using like a TI-8384, then you could just type that in, have the division space, and it's good. But if you have Desmos that you're using, you could go to functions and you see the log, see the difference? There's log and then there's log base A. If you do log base A, it allows you to change the number that's there, and you could do 96. And I'll show you both ways just so that you have it. If you have 96, close your parenthesis, divide it by log of 3, and it is the exact same thing. Okay, and I think this one said what, like 4 decimal places. Yeah. So what we're going to do here is we're just going to write this out. So it's like roughly 4.154. Here's what we're rounding. That's a 4. So 6. Everyone good with that? If we put that in, 4.1546. Any questions about that one? Pretty standard when you're just plugging it into a calculator, right? Or Desmos. Desmos is your best friend, guys. Okay. Now we're looking at these tables, and we want to know which are functions and one-to-one. So if you're looking at these tables, which of these represent a function that is also one-to-one? Okay, so let's think about this. What makes a function? Does anyone remember what makes a function? Right, for every x, there's exactly one y. Which also means that it passes which test? Which test does it have to pass, vertical or horizontal, to be a function? What do you think? Come on, guys, I need your help here. Throw out a guess. Vertical or horizontal to be a function?
Vertical.
Yeah, has to pass the vertical line test. Okay, for it to be a one-to-one, what else does it also have to do?
Pass it horizontally.
Yeah. Which is really just a fancy way of saying for every y, there's exactly one x, right?
All right.
Cool. So which of these tables represents that?
The last one and the third one.
Yeah. If we look at the first one, right here off the bat, we have 2 7s in the x, and they each have a different y. Well, for every x, there's exactly one y. That's what makes a function. So this isn't even a function up here. On the second one, our x's are good. It's the first time we're okay with that. But our y's aren't, right? We have 8 as our y, but it has 2 different x's. So it's a function, but it's not one-to-one. But if we look at the third one, all of it's different, and that's what we want. Okay. And that's really all you're looking for in those tables, is you're just looking for, you want to make sure that all the x's and all the y's are different. There's nothing that's the same. Then you're good. Any questions on that one? Okay. Going to move on. All right, we're getting into more logs. Guys, I love logs. Okay, so which of the following are equivalent to log base b of 5? If we manipulate them in any way, shape, or form, is it possible to get log base b of 5?
Yeah.
Yeah. How about this one? So this one is log base b of 30 minus log base b of 6. What's another way we could write that?
Quotient. Division.
Yeah, no, you got it. Quotient. 30 over 6, right? Because 30 minus 6. And what is 30 divided by 6?
5.
Well, that means that that first one's certainly equivalent, right?
All right.
Okay, how about the next one? We have log base b of 1/10 plus log base b of 50. What's another way we can write that?
Multiplication.
Yeah, you got it. Log base b of 1/10 times 50 over 1. What's that equal?
50 over 10, which is 5.
Which is 5. Well, snap. That means that this is also log base b of 5. How about the next one? How could we manipulate that?
Yeah, that's a good one.
Kind of has to do with this 1/2. Where can we put that 1/2? Right? We could make it the exponent. It's the exponent rule. So then we have log base b of 25 to the 1/2. And what does 1/2 mean as a exponent? What do we do? What are we doing to that 25? Anyone know? When I say I'm taking x to the 1/2, what am I really doing? What am I doing to that x?
Square root.
Yeah, square root. So this is actually the square root of 25, right?
All right.
And what is the square root of 25?
5.
Five. Which means that that is also an equivalent logarithm. What do you think is going to happen with the third one?
Oh, the same thing. Cube root.
Yeah, it's going to be the cubed root. And what's the cubed root of 125?
5.
Yep. And finally, we have one more. Negative log base b of 1/5. We can do the same thing with that negative, right? So this is log base b of 1/5 to the -1. Well, what's that do to that 1/5?
One-fifth. It changed it to negative 5.
Not negative.
I meant 5.
Yeah, it just flips it, right?
Right.
Inverts it to just 5. So all of these are equivalent to log base b of 5. And all of these are demonstrations of the different rules that you use for logs and exponentials. So it's really important to recognize them. If you're struggling recognizing them, make sure you practice before you take your test. Make sure you thoroughly review them before you take your test. Any questions on this one? Okay. Going to continue. This is just plugging it in. What's the issue with a negative?
See. Oh, it can't be a negative inside of log.
Yeah, if we did, notice it says undefined, right? We can't have a negative in there. So this is just D&E. No work involved. Don't even gotta bust out your calculator. The moment you see a negative on the inside, get it out. No bueno. Okay. So here it wants the equation of the vertical asymptote for the function log of x minus 5, and then the domain of the function log x minus 5. Well, there's a couple things you can do here. You could attempt to solve or think about where it's shifted, and sometimes it's just best to graph it. Okay, so I'm just going to do y equals log, and this is x minus 5. Okay. And for comparison, I'm going to show you guys, and this is something you could do too. The comparison is showing you log of x. So log of x, right? The asymptote is what for log of x?
1, 0.
Yeah, this is just so this is the point, right? But the asymptote is x equals 0, right? It's this line right here.
Right.
So what is it for this one?
5.
Yeah, it's just moved over to the right 5, so it's just x equals 5. You guys see that? So going back here, we're just x equals 5. Okay. Man, I gotta stop writing right over the question. Then it wants the domain. Well, if we look at this function again, looking at this one, what do you think the domain is of this function? What are all the possible x values? Where's this one, the blue one? And I'll hide this one. Where's this one start?
Oh, at 5.
Starts at 5, and where's it go till?
Infinity.
Yeah. The other thing to note is that 5 is not included, right? It's gonna get super close. Never gonna touch it. Okay. Any questions about that one? I remember this is where transformations and stuff you guys did on the last test kind of comes into play here, right? Okay. But you always got Desmos, so use your backup. Okay, if f is 1 to 1 and f of 3 equals -11, then what does the inverse of -11 equal?
3.
Yeah, right, because it's switched. And then we've got f of 3 to the -1. So try that out. We have f of 3 to the -1. Well, first off, what's f of 3?
11, -11.
-11. So what this is really asking for the second one is -11 to the -1, which is what?
1 over 11.
Yeah, and it's still negative,
No.
but
Right.
but yeah. Okay. Remember, super important. It's the whole big thing about inverses is that they're switched. If I was looking at and I'm going to clear this. If I was looking at y equals log to the x versus y equals 10 to the x, I gotta zoom out. Okay, if I was doing this, and I looked at that point, that's 1, 0, that's 0, 1. this is, if I can find it, 10-1. This is 110. Okay, so they're switched. Okay, now we've got students in a 5th grade class were given an exam, and during the next 2 years, same students were retested several times. The average score was given by the model f of t equals 87 minus 11 log of t plus 1. And this is between 0 and 24, where t is the time in months. So 2 years in months is 24 months, right? So just when you see the 24, just remember it's dealing with months. So what is the average score on the original exams? Well, what time was it for the original exams? What time do you think we're dealing with?
0.
Yeah. So in this case, for the original exams, we're literally just plugging in f of 0. So then we have 87 minus 11 log of 0 plus 1. Or in this case, 1, log of 1. Right? And you could, if you wanted to, plug that in here. Right? 87 minus 11. Go to your functions, log of 1. And that's just 87. But it's also important to know that log of 1 is 0.
Oh, so it goes away.
Yeah, so that whole thing goes away and it's just 87. The reason being, anything in order for anything raised to a power to equal 1, right, in this case 10 raised to a certain power is equal to 1, it's got to be 0. So log 1 is always 0. Log base anything of 1 is always 0.
So it makes the minus 11 go away as well because it's attached to it?
Well, yeah, because it's just 0 times 11, right?
Right. That's what I'm thinking.
Yep. Okay. So we'll make that 87. Okay. And then it says, what was the average score after 2 months? Well, that's just plugging 2 in, right?
Right.
87 minus 11 log of 2 plus 1. Again, you could just plug that directly into your calculator if you want to, or you can clean it up a little bit. Right? So let's go ahead and do that. And remember it wants it rounded to 1 decimal place. So 87 minus log 3. Oh, what did I forget? I forgot the 11. So 81 point what? 8? Because we're rounding up. So the average score after 2 months was 81.8. And then it says, after how many months does the average score drop below 75? And notice guys, that the score's dropping over the next 2 years. Over the time frame, the average score is dropping. So where do we put the 75 if we're talking about a score? What are we solving for? Are we solving for f of t like we were before? Or are we solving for t? Yeah, good job. T. We're solving for T. So because we're solving for T, we're setting this equal to 75. And then we have 87 minus 11 log T plus 1.
Oh, okay.
Now, here's the one where you can't, it's going to be a little difficult to plug this into a calculator. So you've got to move some stuff around first. So what's the first thing we're doing if we want to get T by itself?
Oh, get all the numbers on the other side.
Yeah, so we'll, and I'm going to change colors here. We'll divide by 87. I'm just kidding. Did you see what I did there? That was bad. Don't do it. We're not dividing by 87. This is adding 87, right? So we're subtracting 87.
Uh,
This is negative 11 log T plus 1. What is 75 minus 87?
negative 12.
Now what are we dividing by?
Negative 11.
Yeah. So that's going to make both of that plus.
Right.
So you have 12 over 11 equals log of T plus 1. What can we do here? What can we do from this point? I'm going to throw it back up here, guys. What did I, does anyone,
Add E to
that was,
both sides.
well, we don't want to do E because we're dealing with log.
Okay.
So E stays with natural log.
Oh, okay. Okay.
What goes with log? What is the base of log?
10.
So rather than E to both sides, we could do 10 to both sides. Or in this case, guys, remember this. This is your golden ticket, right? A to the Y equals X, right? What's our A here?
10.
10. What's our Y?
It would be 1.
It'd be
I mean, yeah.
12 over 11,
12.
right?
Oh, okay.
The whole thing,
Oh, okay.
What's that equal?
T plus 1.
Yeah. Now to get T by itself, we're just going to do T to the 12/11 minus 1 equals T. And we can plug that into our calculator, right? 10 to the 12 divided by 11 minus 1. So when T is roughly 11.3, so after roughly 11.3 months, you guys see that? Yeah, this right here that I wrote in purple is your golden ticket. Do not forget it. It's tattoo worthy. I also say that because I have it tattooed, but it is tattoo worthy. Okay. Moving on. Clear everything first. These are a bunch of logs. It's good to know how to evaluate them without a calculator. Again, this is using our golden ticket, okay? So I'm gonna write that golden ticket up here and I'm gonna write it in orange. So if we're using that golden ticket and I say that log 125 of 5 equals x, how are we rewriting this?
Oh, A is 125.
Mhm.
Y X. Yeah, 125x equals 5.
So 125 raised to the x power is 5. How can we change 125 to be in terms of 5?
We would have to raise it to 1/3. Oh,
Yeah, no, actually yes. So x is 1/3. But if you don't catch that right off the bat, we know that 5 to the 3rd power is 125.
right.
And now we have 3x equals 1 or x equals 1/3.
Right.
So that's what you could do if you don't necessarily make that connection. Good job. And I'll actually, I'll put that in there. Okay. How about log base 6 to the 1/6? How do we rewrite that?
6x equals 1/6.
And how do we get 6 to what power equals 1/6?
-1.
Yeah, just -1. Not 10, not positive 10. Don't do what I did. Okay. Same thing. So log base 9 of 81 equals x. How do we rewrite that?
X equals 81.
And if you see this and you don't know it off the bat, we know that 81 is 9 to what power?
2.
2. So since our bases are the same, x equals 2.
Oh, I see what you're saying. Okay.
Yeah. Anyone have any questions on this stuff, or would you like to see the rest of it?
The 9 with -1.
Yeah, what is it when you have a negative? What's the problem with that?
Oh yeah, it doesn't count. Yeah. Okay.
Doesn't exist. Yeah.
Okay.
Yeah, doesn't exist. Okay. If everyone's cool with that, or does anyone want to see any of these that I haven't done? Let me know in chat or unmute yourselves. And if you're good, we'll move on. Okay, moving on. I feel bad deleting the golden ticket, but it'll be back. Okay, this is the same thing, right? Same exact thing. 2 to the n equals 8. 2 to what power equals 8, guys?
3.
3. Right, 2 to the 3rd is 8. And again, if you didn't see it, by looking at that, we know that 8 is 2 to the 3rd. It's really important to try and get it to have the same base, because once you have the same base, you know that n equals 3. Oh, guys, this is a beautiful one. Okay, so it wants you to write this logarithm as a sum or difference of logarithms with no exponents, and then simplify. What do we do first?
The top
Okay,
is log x plus 14.
x to the 14th, right? Plus
Oh, my bad.
log y
Y
to the 19.
Right.
Okay,
Minus log z to the 10.
well, it's good if you don't write it like I just did. I'm just going to go back and put these in parentheses so it's not confusing. Does anyone have any questions of that part, what he just said? It's important to note that this is division. So you are subtracting that from what's up here. And then this is multiplication. So you are adding those. You want to do division first in this case. All right. From that point, are we done? Or we still have exponents, don't we?
Right.
Yeah, so what do we do with those exponents?
Move them to the front of the log.
Yeah, we're going to move all of them to the front. So we have 14 log base x plus 19 log base y minus, what is it, 10? 10 log base z. Okay, and I will go ahead and input that so you can see it. And then minus 10 log base z. Any questions about this one? You feeling pretty good? Tired of looking at logs with me? Okay. These are more of the same. You evaluate them without doing a calculator. I'm not going to go over them because we just went over them. Just know that E is interchangeable with natural log, just as 10 is interchangeable with log. Shoot, I will go over one. I'll go over B. If we're looking at B here, E to the natural log of square root of 8, what's the answer?
Square root of 8.
Yeah, it's just the square root of 8.
What about D? It look kind of confused.
Okay, yeah, that's a good one. So we have natural log of 6th root of e to the 3rd. How could we rewrite that to be an exponent?
E to D 3/6.
Which is natural log of e to the what?
2. I mean 1/2.
1/2. Okay, and what is natural log of e equal to?
1.
So what is this equal to?
Oh, 1/2. 1/2.
Yeah. And if you're curious why this suddenly equals 1/2, remember this is natural log base e of e to the 1/2. If we use the rule to put that 1/2 in front, we know that natural log base e of e is 1. Okay, and that's how we get the 1/2. And I will actually put that in as well. That was a good one though. Okay. and then submit. There you go. Okay. And again, this is all about remembering properties. Properties are really big when it comes to algorithms. You use them a lot. And it's interchangeable with the exponentials because they're inverses. Okay, so we want you to find the time it takes for $10,000 to double when invested at our annual interest rate of 3.2% compounded continuously. For those of you that saw it, the very first equation we did was a continuous compound interest formula, sort of. It was dealing with bacteria, right? Population going up. But if you look, it's pretty similar, right? The initial times e to the rate times time. And that's what we're doing. So what's our R?
Oh, 3.2, 0.32.
Yep, 0.032, right? Because 3.2% has to go over 1, 2. Okay. All right. And our initial or our A naught. Yep, 10,000. And what are we looking for? What are we looking for? What are we given? We want to know.
Oh,
we know time it takes to double. Well,
right.
If 10,000 doubles, how much is A of t? If it doubles.
20,000.
Yeah. Okay. So knowing all this information and knowing the formula, let's set it up. A of t is 20,000 equals 10,000, our initial, times e to the rate of 0.32. Nope, I wrote that wrong. Let's try that again. 0.032 t. What's the first step?
Divide by 10,000.
Yeah, we're going to divide by that 10,000. And guys, these are zeros. We can cross them out. We know that this is doubled, so we know that it's 2, right? Okay. We're back here again. What golden rule are we using?
Oh, okay, I could say alien. I remember the golden ticket.
Okay, the y equals x is the same as what?
Same as A.
Careful, we already got a to the y equals x. So it's the same as log base what? What's the base?
Of log 10.
Not quite. For the golden ticket?
A.
Mm-hmm.
X.
Equals?
Y.
Yeah, good job. Okay, so we're starting here and we're going there. So our log, and in this case, we don't want to use log, right? Because we're dealing with e, so we're dealing with natural log. Base e, what's our y?
Y is 2.
Yeah, I'm sorry, I should have said x. That was my bad. Equals what? What's our y? Now I'm saying the right thing.
0.32. 0.32.
Times t, right? Okay, so now we have natural log of 2 equals 0.032 t. What are we going to do to get that t by itself? Divide by
Yeah.
0.032.
Right.
And again, do not estimate until the very end. So you're going to take the natural log of 2 divided by 0.032 because this is your exact answer. Okay, this wants it to 2 decimal places. So natural log of 2, let's try that again. Let me clean this up a bit. Natural log of 2, and we're dividing it by 0.032. So we got 21.66. So this is approximately 21.66. 21.66. So it's going to take approximately 21.66 years for it to double, for that money to double. Any questions about this? Okay. I particularly like this one. I am going to go over it because while it's still logarithms, we tend to get some confusion. And so it's really important to understand that we're doing a lot of substitution here. A really good starter example is the first one, log base A of 10. And it wants to know it's approximate. What it's given us is log base A of 5 and log base A of 2. Okay. And it's told us that log base A of 5 is 0.83. And it's told us that log base A of 2 is 0.36. So what you're trying to do is get these logarithms to look like log base A of 5 and log base A of 2 in order to substitute. So something to think about, what times what is 10?
2 and 5.
Yeah, so this is log base A of 5 times 2. How can we split that up using logarithm properties?
Log A 5 plus log A 2.
Right, and then from here, what do we know log base A of 5 is?
0.83.
0.83, and we know that log base A of 2 is 0.36. And because it does say it's approximate, we know that our answer is going to be approximate, but .19. And if you look, 1.19. There you go. Some of the ones that might be a little more difficult to see are like B, 12.5. If you put 12.5 into your calculator and change it into a fraction, you will see it as 25 over 2.
Right.
How could we break up 25 into 5s?
5 squared.
Yeah, so that would be the same thing as saying log base A of 5 squared over 2. Right? And how could we separate that? Log base A of 5 squared minus log base A of 2. Move that 2 out front. 2 log A5 minus log A2. And now we're back to plugging stuff in again, right?
Mm.
We have our 2 times 0.83 minus our 0.36. So 1.3.
Oh, okay, I see.
You see that?
Yeah.
Okay.
And then after that, you gotta times it. Or you can put it in the calculator like that too.
Yeah,
Okay.
yeah, you saw like with Desmos, I just literally put 2
Wow.
times 0.83.
Okay, got it.
The other one would be like square root of 2. Square root of 2, how do we write that in fraction form? 2 to what power?
I guess 1.
It's 1 over something. What's it 1
Oh,
over?
2.
Yeah. So then you have log base A of 2 to the 1/2. Bring that 1/2 out front. And then we know what log base A of 2 is. It's 0.36. So you're taking half of that. And so on and so forth. So 0.18. Does anyone have any questions or want to see the rest of this done? Or does this feel pretty standard? Like, okay, I'm breaking this up into 5s and 2s. I'm using all of the properties on hand and then just substituting. Okay, let's continue. This is just plugging in to a calculator. Literally, natural log 0.3777. And it wants it, oh, I did too many 7s. It wants it to 4 decimal places. 9755 negative. Just put in your calculator. Desmos works. It's all good. And this worked because the inside of this was not negative, right? If the inside was negative, what would the answer be?
Oh, D&E.
Yeah, it'd just be D&E. Now let's get into graphing. So if you get good or you feel comfortable at transformations and you know that what the graph of this is supposed to look like, which is something like, well, not that. Let me erase that. I got a little draw happy. Okay, something like that, being log base A of X. And that is usually what, 1, 0. Then you could do transformations and be like, okay, so it must be here, it must be there. Or you could just graph it on Desmos or graphing calculator and have the answer a lot quicker. I will say when you're doing this on here, the first thing it wants you to put down is the asymptote. So something to think about. What is the asymptote for the original logarithm?
For the original 1.
Yeah, what's the asymptote here? X equals what?
1.
Not 1. What does it never touch?
Oh, 0.
Yeah, it never touches 0. So depending on whether it's been shifted up or down, it's not going to change, right? But if it's been shifted left or right, that's going to change the asymptote. Okay. So really quick, log base 5 of x plus 2. I don't really want to clear that, so I won't. Log. Actually, I'm going to just do function. Base 5 of x plus 2. Okay, so here's our function comparison. Definitely shifted, right?
Right.
What is our asymptote though?
It's still 0.
Yeah, actually that should be, there we go. So it got shifted up, right?
Right.
But the asymptote is still x equals 0. That didn't change. So again, with this, you do the asymptote first. So we're just going to click on the line and click again to have our asymptote. Now you're clicking the graph. And again, for the graph, you just want to find 2 points. So we know that 1, 2 is a point, and we know that 5, 3 is a point. If you can see that. Okay. So 1, 2, 5, 3. Going back to this. 1, 2. Oh, it did it. It did it again. Okay, so again, asymptote first. And then 1, 2. Man, I've had a couple issues with this, guys. Come on. There we go. And then 5, 3. It did that because I had too many asymptotes because it got a little crazy on me. But here, let me try it. Let me see if I can't try it one more time. Doesn't matter where you click those again. Why is it? Oh, that's why. Okay. So for the record, you just got to click it once for the asymptote and it'll plop it down. And then you're going to do your line. There you go. And again, decimals, right? Or graph it on your graphing calculator and then look at the table, right? The table of points. It'll work just as well. Just remember that the vertical asymptote is always x equals 0 unless it shifts left or right. And then however many it shifts is going to be its new asymptote. See if I have a, no, it's not what I wanted. We've already done the continuous. Okay, this is a good one. So this was similar to before. The difference is we have a big one and we need to unfold it first and then we can solve. Let's do B. Okay. How are we going to work on B? What can we do with the fact that that is a square root to separate that?
Right.
And this one goes back to remembering exponent rules, right? If I have the square root of AB, then that is the same thing as saying I have the square root of A times the square root of B. So if I want to break this up, this is the same thing as saying the square root of A squared times the square root of B to the fourth times the square root of C to the third. You could do it that way. What's another way? What is the square root written as an exponent?
1/2.
Yeah. So this is also that, right? The natural log of all of that to the 1/2. Again, these are the same thing, right? It doesn't matter which way you do it. So then if we were doing it this way, you bring the 1/2 out front. You're stuck with the natural log of A squared times B to the fourth times C cubed. And in this case, this is multiplied by that because this is going to expand, right? And if we did it this way, we wouldn't have to worry about that. But in this case, we do. So how do we break this up?
Addition.
Yep. So we have 1/2 A squared plus, man, I don't know why I keep forgetting this. Give me a second. 1/2 in parentheses natural log plus natural log B to the fourth plus natural log C to the third. Okay. What can we do with those exponents on the A, B's, and C's? What can we do? What do we do with the 1/2? At the beginning.
First we need to
Can bring these out to the front, right?
right.
So this is 2 natural log A plus 4 natural log B plus 3 natural log C. And lastly, we know that natural log of A is 2. So this is 2 times 2. We know that natural log B is 3. So this is 4 times 3. And we know that natural log C is 5. So this is 3 times 5. And now we're just doing some arithmetic. So this is 1/2 of what? 2 times 2 is
1/2 of 4.
4 plus 4 times 3 is
12.
3 times 5 is
15.
15. So this is 1/2 of 4 plus 12.
2. I meant 1/2 of 4 plus 12.
Yeah, what's 4
which
plus
is
12?
16. 8.
16
16.
plus 15 is what?
31.
So this is 31 over 2. Okay. Any questions on this one? And again, it is just a matter of, you know how to set it up, you know the properties to use, and you use them. Okay. I'm gonna see what else there is. Otherwise, I will do the rewrite. Okay, so two more, and then we'll call it. So for this one, and we did a little bit of this before, but it worked out really nicely for us, right? And I kind of want to deal with it when it doesn't work out nicely for us. So we have 6 to the x power equals 24. What's another way we could write that?
Six, X, 24. No. It looks like it's already in that form.
We can't really do things in terms of bases, right? Like we can't do 2 to this power is this, and 2 to this power is, that's not going to work here.
Right.
But we have that golden rule. Is log base a of x equals y is the same thing as what? A to the y equals x.
Right.
So let's use it. So we have log, what's our base a?
4.
Not 4.
I mean,
So it's 6 to the x
6,
equals 20. Yeah, it's 6. And in this case, our x is what it's equal to. It's equal to 24. So that is our x. And our y is what we don't know. So log base 6 of 24. And that you just put in your calculator. 6 of 24, which is 1.77. And it wants, oh, it just, this one literally just wants you to rewrite it as a log equation. So
right.
what we wrote, log base 6 of 24 equals x. Okay, so this is literally just using the golden ticket to rewrite stuff. So, and I'll do one of these other ones. If I have log base 2 of 1310 equals 5x, what's our a? Log base 2, our a is 2. What's our x? $13.10. And what's our y? $5x. So it's 2 to the 5x equals 1310. Another way to see it is 2 to this power equals this.
Right.
8 to that power equals that. 9 to that power equals that. Okay. So let's go ahead and write that. So 2.
Oh, have a nice day.
5x equals 1310. Okay. Someone's getting food, and you're gonna make me hungry, Jalen. All right. Any questions about the golden ticket? Golden ticket's pretty solid, right? Log base a to the x equals y is the same as a to the y equals x. Okay, last question. We've expanded a lot of them, but what we haven't done is simplify it. So in this case, we have log base 2 of x plus log base 2 of x minus 7 equals 3. How can we simplify this logarithm so we can solve it? When we have an addition like this, what is it? How do we combine them?
Multiplication.
Yay, you got it, Jalen. So this is log base 2 of x times x minus 7 equals 3. So we could distribute that, and I'm going to go ahead and do that just because it'll be a little bit easier. So x times x is x squared, and x times negative 7 is negative 7x. Well, now we're back to using the golden ticket, right? Because we have log base 2 of this equals this. So log base a of x equals y is the same thing as a to the y equals x. Okay, I'm gonna drill it. You guys are gonna rewatch this video and get sick of me saying this. So a to the y equals x. So 2 to the 3 equals this. 2 to the 3 equals x squared minus 7x. What is 2 to the third power?
8.
8. 8 equals x squared minus 7x. Well, now we're just dealing with a quadratic, and we solve quadratics the way that we've always solved quadratics. We set everything equal to 0. We see if we can factor it. We use the quadratic formula if we need to. So we got x squared minus 7x. We are subtracting 8 from both sides. So minus 8 equals 0. Is this factorable? We can do that, right? 8 breaks up into 8 and 1. And if you have negative 8 plus 1, you got 7.
All right.
8, 1, negative 8 plus 1. So in the end, we have x equals 8 or x equals negative 1. What is the problem with both our answers? Are both of our answers correct? Or do we need to test them?
No, the negative
Yeah.
can't be in the log.
Yeah, this negative right here, not possible, right? Because we have this
Wow.
right here. If it was this one, it certainly wouldn't be it, right? Because then you'd have negative 1 minus 7, so you'd have negative 8. No, we don't want negatives. So the only answer that's going to work, if you check it, because 8 minus 7 is 1, is going to be 8. This has been the review. It's logarithm, so I thoroughly enjoyed it. Does anyone have any questions for me? Okay, well, if you don't have any questions, I am going to go ahead and write my email up here. My email is dannyrowan.hawk@tcc.fl.edu. Okay. Feel free to hit me up if you come up with questions later. Please put your full name in the chat if you have not done so at some point. So that way I know that you attended and I can send you a video later. I will be sending one via your TCC email address, so look out for it tonight. I know some of you have the test to take like tonight to tomorrow, so I'm gonna try and get it done as soon as it's done uploading. So just be on the lookout for it. Thank you otherwise for joining me, and good luck on test 4. We're nearing the end, guys. You got this.
Thank you.